Hello dear student, welcome to another lecture of engineering mechanics. This is lecture number 8, equilibrium of rigid bodies part 2. In the last lecture we started the equilibrium of rigid bodies where we have seen how to apply equilibrium equations in order to solve problems of statics. So we are going to continue that discussion and today we are going to solve a few more problems of that series. Now let's recap whatever we have covered in the last lecture. So we saw the concept of equilibrium. A body is said to be in equilibrium if the resultant of the force system that acts on the body is zero. It means if the resultant forces and the moments acting on the body are zero. Yes. Now equilibrium means that the resultant force and moment both are zero. And there are two types of equilibrium, static and dynamic equilibrium. Static equilibrium means the body is at rest. So automatically the body will be in equilibrium, the resultant force and moment will be zero. Now dynamic equilibrium means the body is moving, but it is moving with constant velocity in the same direction. Now there was a student who asked me this doubt that if a body is under circular motion with constant velocity, will it be in dynamic equilibrium? So what did I say about the dynamic equilibrium condition? The body should be moving with constant velocity in the same direction. And in case of circular motion, the direction of velocity keeps on changing, right? In case of circular motion, at every point the direction of velocity is different, tangential to this circle. So here even if the magnitude is constant, the direction is not same. That's why in circular motion body will never be in dynamic equilibrium. Okay. Now the rotational motion is different. Rotational motion means motion of the shaft. So that motion is different. That can be a dynamic equilibrium problem. But if a particle is like this in circular motion, then it can never be in dynamic equilibrium because the direction of velocity keeps on changing. Okay. Then we saw statically determinate system. Statically determinate system means number of equilibrium equations are equal to number of unknown forces. So you can determine the number of unknowns by applying equilibrium equations. Indeterminate system means number of unknown forces are more than equilibrium equations. So in these problems we need to use extra equations. These problems we do not deal in engineering mechanics. We deal with these questions in strength of materials. Then we saw two special cases of equilibrium. Equilibrium of a two-force system. If there are two forces in equilibrium, their line of action will be same, their magnitude will be same, and they will be opposite to each other. And if there are three forces in equilibrium, they must be coplanar and either parallel or concurrent. First, they must be coplanar. Second, they will either be parallel or concurrent to each other. And then I gave you this question to solve. This was the assignment question. Let's see the solution. Let's see the answer. A sphere of weight 445 Newton rests in a trough as shown in figure. The forces exerted on the sides of the trough at A and B if all four surfaces are perfectly smooth. So we need to find the reaction force at this point and this point. So this sphere is resting on this surface at 45 degree and on this surface at 30 degree. The weight of the sphere is 445 Newton. So if I draw the free body diagram, I am going to get the weight of this acting at the center. Let's say that C is the center. Then there will be one force normal to this surface and one force normal to this surface. Okay, they will be normal to their surfaces. This will be 90 degree and this will be 90 degree. Okay. So what will be their angles? If I calculate the angle of this force with horizontal, it will be 45 degree. And if I calculate the angle of this force with horizontal, it will be 60 degree. How? See, the surface itself is making 30 degree with horizontal, right? The surface is making 30 degree with horizontal. So normal of the surface will be making 90 minus 30 means 60 degree with horizontal. In case of 45 degree, you don't have to worry, right? If this is 45, this will also be 45. 90 minus 45 will also be 45. But here, if the surface is making 30 degree with horizontal, then the normal of surface will make 60 degree with horizontal. So now, there are three forces, so they must be concurrent, and we can apply Lamy's theorem here. We can apply the Lamy's theorem here. So this angle is 45 degree and this angle is 60 degree. So what will be this angle? This will be 75 degree. This is 90 degree and this is 90 degree. This is the weight 445 Newton. The weight is 445 Newton. Then this is RA and this is RB. I told you that if you want to apply Lamy's theorem, one of the forces must be known to you and all the angles must be known to you. So we know all the angles and we know one of the forces, 445 Newton. So we can find RA and RB. So apply the Lamy's theorem, you will get RA divided by sine of the angle between RB and 445 is 150 degree. Then 445 divided by sine of the angle between the other two forces 75 degree equal to RB divided by sine of the angle between other two forces 105 degree. So from here you get RA as well as RB. So what will be RA? It will be 445 sine 150 divided by sine 75. So it is coming out to be 230.35 Newton. And what is RB? It is 445 sine 105 divided by sine 75. So it is 445 Newton only. So 230.35 and 445. 230 and 445. RB is coming out to be 445. Here it is written 145. How come? Let me check again. 445 sine 105 divided by sine 75. It is 445. It means one of the answers is wrong. So we are getting RA 230 and RB 445. This must be 445 then. Okay. So in that case, D will become the answer. RA is 230 Newton and RB is 445 Newton. Yes. Chalo. Okay. We have done something wrong. This angle will be 135. Sorry. This angle will be 135. So 445 sine 135 divided by sine 75. 325.76. Okay, my mistake. This angle was 135. So I am getting 325 means almost 326 Newton. So we are getting B, RA 230 Newton and RB 326 Newton. Okay, sorry. I made a mistake here in the angle. It will be RB divided by angle between 445 and RA. 90 plus 45 means 135. Chalo. The answer will be B. RA equals to 230 and RB is equals to 326 Newton almost. Chalo. So now let's begin the series of questions. So in equilibrium of rigid bodies, we have seen one type of problem where a body is resting on two surfaces and we are applying Lami's theorem to solve the problem. Now there are variety of questions that you can solve in this particular topic. So let's see what other type of questions you might get. Now this is a very famous question. A roller of radius 30 mm and weight 1000 Newton is to be pulled over a curb of height 15 mm by a horizontal force P applied to the end of the string bound around the circumference of the roller. Magnitude of force P required to start the roller over the curb is. So here what do we have? We have a roller which is right now resting on two surfaces. It is resting on this horizontal surface and it is resting here on this curb, and we are applying a horizontal force on this roller. Now in order to just start this roller, what should be the value of this force P? So understand about the situation here, understand about the criteria here. What they are saying is we need to apply a force just enough to start this roller. See, you can pull this roller with a very high force. What will happen? This roller will jump on this curb and it will accelerate towards right. But they are not asking you to take this roller away from this. They are just saying, tell me the minimum amount of force P required to just start the roller. It means, let's say I calculate that force to be 500 Newton. I am just giving you an example. Let's say I say that the minimum force required to start this roller is 500 Newton. It means even if you apply more than 500, it will move, right? Let's say you are applying 600 Newton, then also it will move. 800 Newton, then also it will move. 1000 Newton, then also it will move. But if you apply less than 500 Newton, it is not going to move from its position. So what that 500 Newton is the minimum force which will start this roller. So you need to just calculate that minimum force. Okay. Now in order to calculate that force, we are going to assume that this roller is just about to climb this curb. This roller is just about to climb this curb. So right now this roller is touching here and here, right? Let me call this point as A, this point as B, this point as C, this point as D. So I am assuming a situation when the roller is just about to start. It means this roller will start losing contact from this point A. That is going to be your condition to find out the force P. How will you know that the roller is just about to start? When it will start lifting from this point, right? Till then it will not move until and unless this surface lose contact from the roller is not going to move. So at the point when it is just about to start moving, it will lift off from this surface. It will lose contact from this point. So assume that condition and draw the free body diagram. So if I draw the free body diagram, assuming that condition, I am going to get a diagram like this. This is the roller. Let me mention all the points here. This is point A, this is point B, the center is point C and the top is point D. So draw the free body diagram. Good evening. So we will get the weight of this roller. How much is the weight? The weight of the roller is 1000 Newton. So that is acting at point C. Then there is force P at point D, which is horizontal. Okay. Now at point A, we have to assume that it is lifted off the surface. We are assuming the roller is just about to start moving. So it will lift from this surface A, it will lose contact from this surface. So there will be no reaction at A. If you are drawing reaction at A, you are assuming that this roller is not moving. So the difference between the FBD of roller moving and roller not moving will be this reaction. If you are applying the reaction, roller is not moving. If you remove the reaction, roller is moving. Okay. Now, there will be one reaction at point B also. Now comes the interesting part. Understand this very carefully, because whenever I ask this question, 95% people, almost 95% people make mistake in answer. If I apply a reaction at B, from which point should it pass through? Will it pass through point C like this? Like this? Will it pass through point C like this? Of course, sir. All the forces acting on the sphere should pass through the center only. So the reaction at point B will also pass through center C. No. This is where most of the people make mistake. The reaction will not pass through point C. Why? Because how many forces do you see here? There are three forces, right? There is a horizontal force P. There is a vertical reaction at, the weight of roller at C, and there is a reaction at B. So we have only three forces. Now, according to the equilibrium of three forces, if there are three forces acting on a body and the body is in equilibrium, they will be coplanar and they will be either parallel or concurrent. Now, these three forces are coplanar and they are not parallel, so they must be concurrent. Now, if this reaction passes through point C, will all three forces be concurrent? No. So that is why it is not going to pass through point C. So from where will it pass? So understand, this weight and this force P, they are intersecting at point D, right? Yes, very good. So the reaction at B will also pass through point D. So here will be the reaction RD. I hope it is clear to all of you. I hope it is clear to all of you. So now understand. I want to find the value of this force P. This is P, this is 1000 Newton and this is RD. So in order to calculate force P, you have two choices. You can either apply summation of Fx or we have three choices actually. You can either apply summation of Fx equals to 0 and summation of Fy equal to 0. Okay. Or you can apply Lami's theorem, okay, or you can also take moment at point B. If I take moment at point B, moment of this RD will be gone and I will get the moment of P and 1000 Newton. From there I will calculate the value of P. So you have three choices: summation of fx, summation of fy, first choice; second choice, Lami's theorem; and third choice, taking moment at point B. You can use any one of these methods to find out the value of P. I will choose the third method because it will take less number of equations to solve, right? So what I am going to do is, I am going to take moment at point B. Okay, in order to take moment at point B, I have to find the distance of force P from point B. I have to find this distance, right? I have to find the distance of this 1000 Newton also from point B and force P from point B. So this 1000 Newton, let me first draw this line. Okay, this is the center C. Okay, now what I am going to do is, I am going to draw a triangle like this. Can you see this triangle? Yes. Now in this triangle, I know this distance. This will be the radius BC, 30 mm, right? Now I also know this distance. What will be this distance? This is 15 and this is 30. So this will be 15. Look at this distance. This is also, AC is also radius, right? AC is also radius, and this distance is equal to the height of the curve, 15. So this remaining distance will also be 15. So this is 30, this is 15. So from Pythagoras, I can find this distance. What will be this distance? Root over 30 square minus 15 square means 25.98. This distance will be 25.98, almost 26 mm. And I know this distance also. This distance is also 30. So now I have all the distances I need. So I can take moment at point B. So if I take moment at point B, moment of this RD will be gone. Okay. Moment of P will be clockwise and it will be 30 plus 15. Right? Moment of P will be clockwise and the distance of P from B, vertical distance, will be 30 plus 15. Moment of this 1000 Newton will be anti-clockwise. Okay, and the distance of 1000 Newton from point B will be this horizontal distance, 25.98. So from here I will get the value of P. So 25.98 into 1000 divided by 45, I am getting 577.33 Newton. You know what is this force? This is the minimum force. Very good, very good. This is the minimum force required to start the roller from moving. If you apply a force less than this much, it is not going to move. So in order to move, you have to apply a force equal to or more than this much. Then it will start moving. It will jump on this curb and it will go away. And this is a very famous question, let me tell you. You get lot of questions from this concept. Okay. Let's move on to the next question, and this is an MSQ question. What do we mean by MSQ question? MSQ means multiple select question, where you might have more than one correct answers. There can be 2 correct answers, there can be 3 correct answers, there can even be 4 correct answers. Okay. A light string ABCDE whose end A is fixed has weights W1 and W2 attached to it at B and C. It passes over a frictionless pulley at D carrying a weight of 300 Newton. Which one or more of the following statement is or are correct? The weight W1 is 86.6 Newton, weight W2 is 229.8 Newton, tension in AB is 120 Newton, tension in BC is 150 Newton. So what they are asking you to calculate is tension in this and W1 and W2. Now, if you look at the diagram of this string is passing over a frictionless pulley. Now, whenever a string passes over a frictionless pulley, then the tension on both sides of the string will be same. If it is passing over a frictionless pulley, tension on both sides will be same. If there is friction, tension on both sides will be different. So when there is friction between string and pulley, then how to solve the problem? That we will see in the next chapter, friction. But in this chapter, we will ignore the friction. We will assume in the question itself they have said that there is no friction between the string and the pulley. So tension on both sides will be same. Now on this side of the string, what will be the tension? It will be equal to this weight 300 Newton, right? This tension will be equal to 300 Newton. So this tension on the other side will also be equal to 300 Newton, right? How to draw the free body diagram? Cut it from here, cut it from here, okay? So this tension will be there, 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 okay? Let me call it TCD. So this tension in TCD, it will all be equal to 300, right? Look at the FBD of this block. There is weight 300 Newton acting downward and tension upward. Only two forces. So this tension will be 300. If this is 300, this will also be 300, right? Equal and opposite force. Now, it is a frictionless pulley. So tension on this side and this side must be same. So here tension is 300. So here also tension will be 300. And this tension will also be same, equal and opposite. So here you know the tension. Now can you draw the FBD of this joint C? C is a joint. Okay, we have tied a knot in the string. So don't think that the tension here and here will be same, because this is now like a knot. So it will be like a joint. So draw the FBD of C. Cut it from here also. So now beta, if I draw the FBD of C, what I am going to get, understand? This will be the tension 300 Newton. This is W2. And this will be tension in BC. This is the angle 120 degree. So this will be 90 degree. And this will be how much? 90 plus 120, 210. So 150 degree. So now this is C. So now we can apply the Lami's theorem, right? So according to Lami's theorem, tension in BC divided by sine of angle between W2 and 300. It will be 150 degree equal to W2 divided by sine of angle between TBC and 300, 120 degree equal to 300 divided by sine of angle between TBC and W, 90 degree. So now TBC by sine 150 equal to 300 by sine 90. From here you will get TBC. TBC by sine 150 equal to 300 by sine 190. So 300 sine 150, you are getting 150 Newton. And W2 will be equal to 300 sine 120 divided by sine 90. So this is 259.8 Newton, means almost 260 Newton. So tension in BC is 150 Newton. So this is correct. This statement, D statement is correct. And W2 is 259.8. But here they have written 229.8. See, in order to confuse you. Okay. So B statement is wrong. Okay. B statement is wrong. Now, yes, you can say that TBC is horizontal component of 300 and W2 is vertical component of 300. You can call it. You can say that. Okay. Now, we will draw the FBD of joint B. So if I draw the FBD of joint B, then what we are going to get? W1 acting vertical, this will be TBC, and this will be TAB. So TBC we have already calculated 150 Newton, right? And this is W1, this will be TAB. This angle is 150 degree. This is 90 degree. So this will be how much? 150 plus 90, 240. So this will be 120 degree. Now use Lamy's theorem again. So it will be TAB upon sine 90 equal to W1 upon sine 150 equal to 150 upon sine 120. So from here we will get TAB and W1. So what will be TAB? 150 sine 90 divided by sine 120. So I am getting 173.2 Newton. And then W1 will be equal to 150 sine 150 divided by sine 120. So I am getting 86.6 Newton. So W1 is 86.6 and TAB is 173.2. W1 is 86.6, very good, correct. And tension in AB 173.2. So answer A and answer D are the correct answers, right? Statement A and statement D are the correct statements. B and C are the wrong statements. So this was a question again on the application of Lamy's theorem. Let's move on to the next question. Now this is a very interesting question. We are going to see a very interesting concept here. a 5-meter bar of negligible weight rests in a horizontal position on the smooth plane. Find the distance x at which load W equal to 100 kilonewton must be placed from point B to keep the bar horizontal. Understand the question here. What they are saying is, we have a bar, 5-meter long bar, okay, of negligible weight. It is resting in horizontal position. The bar is horizontal right now. There is one surface at 30 degree with horizontal here, and there is one surface at 45 degree with horizontal here. Now, the distance of 200 kilonewton force from left end is given 1 meter, and you need to find distance of 100 kilonewton force W from this right end. Okay. So in this question, we have to find the distance x. So how are we going to solve this problem? First of all, we need to draw the free body diagram of this bar. Okay. So let's draw the FBD of the bar. This is point A, this is point B. So at point A and B, we have two reactions. Now the reaction will be normal to the surface. Okay. The surface is at 30 degree with horizontal. So the reaction at A will be at 60 degree with horizontal. Similarly, here the angle will be 45 degree. Surface is making 30 with horizontal, so the reaction will make 60 with horizontal. Reaction is normal to surface. So this is RA, this is RB. Now 200 kilonewton acting at 1 meter from A. So what will be the distance of this 100 kilonewton? This is 200 kilonewton. This is 100 kilonewton. Okay. We have this distance. We need to find this distance. This distance is 1 meter. Let's say this distance is x meter. So we need to find the value of x. So how are we going to find the value of x? In order to find the value of x, it is obvious that we have to take moment. Okay. We will take moment at point B. If I take moment at point B, I will get the distance x. But in order to take moment at point B and find x, we should know the value of RA. We will not need RB. We will not need RB because we are taking moment at B. So the moment of RB will become 0. So we will not need RB, but we will need RA, right? Then only there will be only one unknown in the equation, x. So how do we calculate RA? In order to find RA, we will apply Lamy's theorem. But you must be wondering, sir, there are 4 forces and that too they are not concurrent. So how you can apply Lamy's theorem? Understand, beta. It is not necessary that for applying Lamy's theorem there must be only 3 forces and they must be concurrent. No, I never said that Lamy's theorem is only applicable when there are 3 forces and they will be concurrent. No, here also you can apply Lamy's theorem. For applying Lamy's theorem, there must be n number of forces. There can be n number of forces acting on the body, but they must be acting in only 3 different directions. There can be n number of forces, but they must be acting on only 3 directions. So here we have 4 forces, but they are acting in only 3 different directions. 2 of the forces are acting in the same direction. Yes? And they did not need to be concurrent. Okay, for applying Lamy's theorem, the forces need not to be concurrent. Okay, they need not to be concurrent. Even if the forces are not concurrent, we can still use Lamy's theorem. So here we have 4 forces, but 2 of the forces are in the same direction. So we can apply Lamy's theorem. How? Look at this. We will have vertical force 200 plus 100, which will become 300 kilonewton. Then there will be RA acting at 60 degree, and then there will be RB acting at 45 degree. 100 plus 200 means 300 kilonewton. This is RA and this is RB. So now you can use Lamy's theorem. This is 60 degree. This is 45 degree. So this will be 75 degree. This is 90 and this is 90. So apply Lamy's theorem and find the value of RA. We don't need RB, okay? So RA divided by sine of 90 plus 45. This will become 135 equal to 300 divided by sine of 75. So what will be the value of RA? 300 sine 135 divided by sine 75. I am getting 219.61 Newton. So I have got the value of RA, 219.61 Newton. Okay, sorry, kilonewton, not Newton, kilonewton. My mistake. And now once you get the value of RA, you can find the value of X by taking moment at point B. What I am going to do is I am going to copy this diagram again. This time what I am doing is I am resolving the force RA into 2 components. So this will be RA cos 60. This will be RA sin 60, right? Now if I take moment at point B, the moment of RB will become 0 because it is acting at B. The moment of RA cos 60 will also become 0 because this is also passing through point B. So I will get moment of RA sin 60, 200 kilonewton and 100 kilonewton. Let's take moment at point B. Net moment at point B will be 0. So it will be RA sin 60 and RA is 219.61. So 219.61 sin 60 multiplied by, what is this total distance? 5 meter. And this moment will be clockwise. Moment of this 200 and 100 will be anti-clockwise. So minus 200 into distance from here to B will be 4 kilonewton minus 100 into X. So from here you get the value of X. So 219.61 sin 60 multiplied by 5 minus 200 into 4 divided by 100. I am getting 1.509, means almost 1.51 meter. I hope this is the answer you getting. Yes, 1.51 meter, almost 1.51 meter. So I hope you learned something new here. I hope you learned this concept that even if there are n number of forces acting on a body and even if they are not concurrent, we can still use Lamy's theorem, provided that the forces must be acting only in 3 different directions. Yes. Okay. Let's move on to the next question. Now this is another interesting question. This is an MSQ question again. MSQ question means multiple answers can be there. Now here we are going to see something interesting. A 600 Newton cylinder is supported by frames BCD as shown in figure. The frame is hinged at D and supported by frictionless surfaces at A and B and C. Understand what is happening. We have a cylinder of weight 600 Newton. Okay. It is supported by a frame and a wall. Okay. This is the wall and this is the frame. Now, thank you so much, Sanjay. Thank you so much for the compliment. Now, here, here and here we have frictionless surfaces. Okay. So this cylinder is touching three surfaces. All three surfaces are frictionless. See, in this chapter, we are just understanding how to apply equilibrium equations, how to draw FBD and apply equilibrium equations. So we are ignoring the friction forces. In the next chapter, we will include the friction forces. Okay, so right now we will assume all the forces to be frictionless for the ease of solution. Right now, let's not complicate things. Let's just understand how to draw FBD and apply equilibrium equations. Okay, so here these surfaces are assumed to be frictionless, and this is a frame which is hinged to the wall. This is a hinge support. Okay, now we need to find the reaction forces at A, B and C. Look at the statements. We need to find reaction forces at A, B and C. So what you need to do is, you need to draw the free body diagram of this cylinder. Draw the free body diagram of the cylinder. So this is our cylinder. Let me draw the points A, B, C and the center is O. This is the center O. This is A, this is B, this is C. So if I draw the free body diagram, we will have the weight of cylinder acting at the center, 600 Newton. Then there will be reaction at C, normal to the surface. There will be reaction at A, normal to the surfaces. Both the surfaces are vertical, so reaction at A and C are horizontal. And normal reaction at B, the surface is horizontal, so the reaction will be vertical. So this is RC, this is RA, this is RB. Now look at the free body diagram. How many unknowns do you see here? I see three unknowns. I see three unknowns, RA, RB and RC. And how many equilibrium equations do you have here? How many equilibrium equations do you have here? You have only two equilibrium equations. How? Sir, we must have three equilibrium equations. Summation of fx equals to 0, summation of fy equal to 0, summation of m equal to 0, right? We have three equilibrium equations. Then how come there are only two here? Because all the forces are concurrent. So here we have only two equilibrium equations. So we cannot find all three unknowns here. Now some of you might be wondering, some of you might wonder in future also, if someone sees this recorded lecture, some of you might wonder, sir, I can take moment at C, na? I can take moment at B. I will not take moment at O. All the forces are passing through O, so I will not take moment at O, but I can take moment at A, na? I can take moment at B, na? So I can use summation of m equal to 0. Now understand this very beautiful concept here. When I say that you have three unknowns and only two equilibrium equations, I mean that you have two independent equilibrium equations. Do you know what are dependent and independent equations? Let me give you an example. X plus 2y equal to 5. How many equations do you see here? Do you see here? You see one equation, right? So can you find the value of x and y? No, you can't. If I give you another equation, 2x plus 4y equal to 10. Now how many equations do you see here? You see two equations. So can you now find the value of x and y? Can you now find the value of x and y? You have two equations. So can you now find the value of x and y? No, you can't still not find the value of x and y. Why? Because this is a dependent equation. It is not an independent equation. This is a dependent equation. If you multiply 2 in this equation, you will get this. Look at this equation. Multiply it by 2. It will become 2x plus 4y equal to 10. So will you be able to solve this equation? Will you be able to solve this? No. So beta, here although we have two equations, we still can't find two unknowns because one of this equation is dependent on the other equation. Yes, you can make infinite equations like this, but that doesn't mean you have infinite equations. There is only one independent equation. So number of unknowns must be equal to number of independent equations, not total equation. Total, so there is always infinite equations. So here beta, by taking moment at different points, you will get infinite equilibrium equations. So does that mean we have infinite equilibrium equations? No. We have only two independent equations here. In most of the problem we have three independent equations, but here we have only two independent equations. Even if you take moment at any point, now you will never be able to solve the problem. Let me give you an example. If I take moment at B, moment of RB and moment of 600 both will become 0. Moment of RA will be RA multiplied by this distance and moment of RC will be RC multiplied by this distance. So beta, what you are going to get by taking moment at B? RA equal to RC, right? If I take moment at B, you get RA equal to RC. And from summation of fx equal to 0, you already have RA equal to RC. Right? By summation of fx equals to 0, you already have RA equal to RC. So didn't I tell you that even if you take moment at any other point, it will not give you a different equation. You will get the same equation. If I take moment at B, I will get this equation only, RA equal to RC. So that is a dependent equation. I hope now you understand. Although you can take moment, but still you have only two equilibrium equations, independent equilibrium equations. Yes. So from summation of Fy equal to 0, I will get RB, which is 600 Newton. RB is 600 Newton. So yes, I have got one reaction, RB, which is 600 Newton. RB is 600 Newton. Yes, this statement is correct. But how to find the value of RA and RC? Even if I get one of them, the second one will also be equal to the same. So how to find either RA or RC? So here comes the interesting part. Although we don't have enough equilibrium equations for this cylinder, we can still solve the problem by considering the free body diagram of the frame. So in this problem, you have two different bodies. You have the cylinder and you also have the frame. We can draw the FBD of the frame. You can draw the FBD of the frame. Yes. So you will find these type of questions also in statics, where you have 2-3 different bodies connected together. If you consider one of these bodies, you will not be able to solve the entire question. You might have to consider 2 or 3 of the bodies. So here beta, by considering only cylinder, I will not be able to solve the problem. I will have to consider the FBD of the frame. So let's draw the FBD of the frame. So if I draw the FBD of the frame, what I am going to get, understand. Look at this. This is the frame. This is point D. This is point C. And somewhere here is point B. Yes. Now, whatever forces here you are getting na RB and RC, they will be equal and opposite on the frame. So RB will be like this, RC will be like this. These are the forces acting between cylinder and frame, right? So whatever direction you are getting on cylinder, they will be opposite on frame. Value will remain same. Now beta, at point D, it was hinged, right? So if I remove the hinge, I will get 2 reactions here. I will get 2 reactions here. I don't know their directions. I am just assuming. But I don't need to find their values. I need to find RC, right? So how to find RC beta? Just take moment at point D. Just take moment at point D. If you take moment at point D, moment of RDX and RDY will be 0. You will get moment of RC, you will get moment of RB. Now what is the distance of RC? What is the distance of RC from here? So beta, look at this cylinder. This total height is 600 and this distance is 150, right? This is the radius. So this distance from here to here will be 600 minus 150, 450. This will be 450 mm. Yes. And the distance of B from D will be equal to radius 150. This distance is 150. So now you can take moment. So moment of RC will be clockwise, RC into 450, and moment of this 600 will be anti-clockwise, 600 into 150. So what will be the value of RC? 200 Newton. So RA will also be 200 Newton, right? RC is 200 Newton. So RA will also be 200 Newton because RA is equal to RC. So RA and RC both are 200. So this statement is correct. This statement is correct. D statement is wrong. So we now have 3 answers, A, B and C. So this was a very interesting question where we had 2 different bodies. So just by considering one free body diagram, we were not able to solve the problem. So we considered 2 free body diagrams. Let's move on to the next question. Now this is another interesting question, and let me tell you, you will find this type of question in previous year question also. In GATE also, you will find this type of question in exam. Now another MSQ question. Let's solve this one. 2 smooth spheres, each of radius 100 mm and weight 100 Newton, rests in horizontal channel having vertical walls. These are horizontal channels having vertical walls. We have 2 spheres, both are smooth, no friction. The distance between the channel vertical walls is 360 mm. Which one or more of the following statement is or are correct? So you have four statements. Reaction at A is 100 Newton, reaction at B is 166.67 Newton, reaction at C is 200 Newton, and reaction at D is 133.33 Newton. So here in this problem, they are asking you to find reaction here, 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 and here. Okay, this is the B point. This is the B point. Okay, so A, B, C, and D. So how to solve this problem? Understand. Here, if I draw the free body diagram of this sphere, how many unknown forces I will get? One unknown force will be here, one unknown force will be here, only two unknown forces. So I can solve the free body diagram of the top sphere O1, this first sphere, right? Now the reaction acting between both these spheres will be acting from this center to this center. Okay, if you are confused about the direction of reaction at point B between these two spheres, it will be directed from this center to this center. This will be the direction of reaction acting between these two spheres. This sphere will apply force on this sphere, this sphere will apply force on this sphere. So what will be the direction of reaction? From this center to this center. Okay, so let's draw the free body diagram of this sphere. This is point A, this is O1, and this is point B. Okay, now the spheres have a weight of 100 Newton. So weight of 100 Newton acting here. There will be a reaction at A normal to the surface. So the wall is horizontal, and there will be a reaction at B like this. So this is RA and this is RB. Now RA is horizontal, this 100 Newton weight is vertical, but what is the angle of RB? So you will have to calculate that angle from this diagram. Okay, from this diagram you can find the value of this angle alpha. How to find the angle alpha? Look at this, look at this, look at this. Look at this triangle. You will have to look at this triangle. What is this distance? This distance is radius 100 mm. What is this distance? This distance is also equal to radius 100 mm, and this is 360 mm, right? So what will be this distance? This distance will be 360 minus 200 means 160. Yes. What is this distance? This distance is 100. What is this distance? 100. So what is this total distance? This total distance is 200. So now for this triangle, I can find the value of angle alpha. This is 160, this is 200, and this is angle alpha. So alpha will be cos inverse of 160 by 200, right? Cos alpha will be base by hypotenuse, na? So cos inverse of 160 by 200, I am getting 36.87 degree. I am getting 36.87 degree. Yes. So I have the value of angle alpha. So now I can find the value of RA and RB. Yes. Apply Lami's theorem, beta. Apply Lami's theorem, na. Apply Lami's theorem. And you will find the value of RA and RB. This angle is 90 degree. Okay. This angle is 36.87 degree. What will be this angle, beta? Let me draw a simple diagram for you so that you can understand. Okay. This is 100 Newton. This is RA. And this is RB. 100 RA RB. So this angle is 36.87. This is 90. This is 90. This will be 180 minus 36.87. Means 143.13 degree. Okay. So now I can find the value of RA and RB by applying Lami's theorem. So RA divided by sine of the angle between these two, 126.87 equal to 100 divided by sine of 143.13 equal to RB divided by sine of 90. So what are the values of RA and RB? Solve this equation. Tell me what are RA and RB. 100 sine 126.87 divided by sine 143.13. I am getting RA 133.33 Newton. Similarly, RB 166.66 Newton. I hope you are also getting the same. RA 133.33, RB 166.66. Very good, very good. So now we have two of the answers. RA 100 Newton, no, this is wrong. And RB 166.66, yes, this is right. Very good. Now we need to find the reaction at C and D. We need to find the reaction at C and D. So you have two choices. Now comes the interesting part. You have now two choices. What two choices do I have? You can either draw the free body diagram of this sphere. If you draw the free body diagram of this sphere, you will get one reaction here, one reaction here, and one reaction here. You can solve this because this reaction you already know. So you can find this reaction and this reaction. Okay. Or what you can do is, you can draw the free body diagram of both these spheres together. What will be the advantage, sir? If I draw the free body diagram of both these spheres together, we don't need to consider this reaction. If both are connected, then we don't need to consider the reaction between them. Na? Both are applying equal and opposite force on each other. So the reaction here will be cancelled. So I will get one reaction here, one reaction here, one reaction here, means all the forces will be either horizontal or vertical. We will not get any reaction at an angle. I hope you understand. If you don't understand, draw the FBD. Draw the FBD of both the spheres together. Draw the FBD of both the spheres together. This is one sphere. I will just copy it and make another sphere. This is A, this is O1, this is B, this is O2, this is C, and this is D. So now understand what will be the forces. Weight of both the sphere, 100 Newton acting at their center. One reaction here which I have already calculated, one reaction here which will be vertical, one reaction here which will be horizontal. I don't need to consider the reaction acting at B. Equal and opposite reactions cancelled each other. So what is RA beta? RA is 133.33. Let's say this is RC and this is RD. So now it is so easy to calculate RC and RD, right? I hope you now understand why I have considered both the spheres together, right? So from summation of Fx equals to 0, you will get RD, which will be 133.33 Newton. And from summation of Fy equal to 0, you will get RC. It will be 100 plus 100 means 200 Newton. So simple, right? So RC will be 200 Newton. This is correct. RD is 133.33. So this is correct. So we have three correct statements, B, C and D. Yes. Chalo. So even in this problem also, in the last problem also, we draw the free body, we have drawn the free body diagram of only this. But what we can do is, we can also draw the free body diagram of this cylinder plus frame. So if you draw the free body diagram of the cylinder plus frame, you will not get reaction here and here, but you will get the weight of cylinder and the reaction force at A. So it will almost be the same. So here there will be no advantage of drawing cylinder and the frame together. But here there is an advantage. What advantage is that? We got all the forces either vertical or horizontal. So our solution became quite simple. Yes? Chalo. Let's move on to the next very interesting question, and this is that next very interesting question. Read the question very carefully. In the frictionless pulley system shown in figure, each pulley weighs 40 Newton. The weight W that can be lifted by the system under the condition shown is. Each pulley has a weight of 40 Newton and we are lifting this W. So what will be the value of this W under equilibrium condition? So understand. In order to find the value of W, I will have to draw the free body diagram of this orange box. Okay, I will have to draw the free body diagram of this orange box. So if I draw the free body diagram of this orange box, see, I will cut it from here and here, right? So there will be this tension and this tension. So if I get this tension, I will get the value of W. Now this is the same rope, na? This rope is passing through this pulley, then this pulley, then this pulley, then this pulley. So this is the same single rope passing over three frictionless pulleys. All the pulleys are frictionless, so this tension will be same. If this is T, this will also be T. So if I find the value of T, I will get the value of W. Now look at this. Cut it from here and here. This will be tension T, tension T. Same tension, na? Same rope, same tension. Now draw the FBD of this blue wala pulley. This blue pulley. This is 100 Newton. This is tension T. This is tension T. Now, most of the people make mistake here. They ignore one force. And what is that force? That force is the weight of the pulley. Each pulley is weighing 40 Newton. So you will have to add the weight of the pulley also. 40 Newton. So this is 100 Newton, this is 40 Newton, this is T, this is T. So from summation of Fy equal to 0, you get 2T equal to 100 plus 40, means 2T equal to 140 Newton. Yes, 2T equal to 140 Newton. Now you can draw the FBD of this. So this is the weight W, this is T, this is T. So if you apply summation of Fy equal to 0 here, W will be 2T, means W will be 140 Newton. Yes. So this was an interesting question, because if you ignore the weight of the pulley, you will get the wrong answer. And most of the people do that. Most of the people give the answer to be 100 Newton because they ignore the weight of 40 Newton. You also did the same. Yes. Chalo. Now let's move on to the next question. So this next question is also related to pulleys. Neglecting the friction and weight of pulley, ratio W by P to maintain equilibrium is. So this is your weight P, this is P and this is W, and we have 1, 2, 3, 4, 5 frictionless and weightless pulleys. Okay, we have 5 frictionless and weightless pulleys. We need to find the ratio of W and P. Now how to solve this problem? So in order to solve this problem, first you draw this diagram, this entire diagram, and draw it bigger. Okay, draw it bigger. Okay, take the entire page of the notebook, okay, and draw this diagram, because in the diagram itself we will make calculations. Okay, because here we don't need to consider the weight of pulley, so you just need to be careful with tension. If you need to consider weight of pulley, then I will suggest that you draw the FBD of this pulley separately. But if you don't need to consider the weight of the pulley, in the diagram itself you can make calculations. So what we are going to do is, we are going to start from one end. Let's say that one end is this. Okay, so what will be this tension? This tension will be equal to P. And this is the same rope, right? This is the same rope passing over frictionless pulley. So if this is P, what will be this tension? This tension will also be P. Yes. Now this is the same rope. This is the same rope. Yes. So if this is P, this is also P. Now this is the same rope. So if this is P, this is also P. I hope you have got this. Now we have 3 P's. 1, 2, 3. So total here, what will be the value of tension? This will be 3P. Yes. Now this is the same tension, na? This will also be, let me draw it like this, otherwise you will get confused. This will also be 3P, because this is the same rope and this is also the same rope. So this will also be 3p. So now what will be value of W beta? W will be 3p plus 3p plus 3p. So W will be 9p. So W by P will be 9. Yes. So in the diagram itself, you can make calculations because you are not considering the weight of the pulley. But if they give you the weight of the pulley, then draw the FBD of pulley separately. Otherwise, you will get confused. I hope that this is clear to you. So you might get questions on the arrangement of pulleys like this. Chalo. Now, this next question is your assignment. This next question is your assignment, okay? I will give you a hint to solve this question. 3-hinged arc is loaded as shown in figure. Which one or more of the following statement is correct? So what you have here is an arc which has 3 hinges. One hinge is here, another hinge is here, and there is one hinge here also. Now, if you remove this support and this support, you will get 4 reactions, 2 here and 2 here. So you will not be able to solve this problem. So in order to solve this, because you have 4 unknowns and you have only 3 equilibrium equations, you will have 2 reactions here and 2 reactions here. So you will have 4 reactions and only 3 equilibrium equations. So in order to solve this problem, what you need to do is, you need to separate these 2 arcs. So draw one free body diagram considering this entire arc, and then draw second free body diagram considering either this half or this half, because both are connected using a hinge. So you can draw the FBD of this half or this half. You don't need to draw both. Draw any one half. Okay. So you'll have to draw at least 2 free body diagram. One free body diagram of this entire arc and one free body diagram of either this half or that half in order to solve this problem. So let's see tomorrow whether you will be able to solve this problem or not. Okay. I will give you the answer tomorrow. So thank you for joining. I will see you tomorrow at the same time, 7 p.m. sharp. Till then, bye-bye, take care and good night.